This is Math 8, Section 3.2, identifying the number of solutions to a linear equation. So let's understand and identify linear equations with no solution. Now, so far, everything you've had has had one solution because it's like x equals something. For example, x plus 4 equals 9. Well, we subtract 4, and that tells us that x equals 5. Okay, so x has had one solution. But it's possible for it to have 0 solutions. Like if we try to solve x plus 4 equals x, well, I could put both the x's on the same side. So if I subtract x from here and subtract x from there, that's going to give me 0 plus 4 equals 0. And I have no solution because it just tells me that 4 equals 0, but we know that 4 does not equal 0, so therefore there's no solution. So if you have an inconsistent equation, something that is untrue, you know that there are no solutions. So basically, if there's no possible way I could put in a number for x that would make this true, then there are no solutions for this problem. Impossible. Let's try an example. Example 4. And it says, tell whether each equation is inconsistent. Justify your answer. So let's try it. 5x plus 3 equals 5x plus 3. Okay, let's see if this has a solution or not. So first we are going to distribute this to both. So we get 5x plus 3 equals 5x plus 3. Now if we try to move these things around a little bit, so move both of the x's to one side, so minus 5x, and then minus 3 to move that around, so we have to do the same thing to both. Well, if we, oh sorry, this would not be 3. 5 times 3 is 15. That's why I was confused. Okay, so we're trying to move the 3 from that side over and the 5 to that side over. So we subtract both from the same side. This becomes 0. That becomes 12. That becomes 0. That becomes 0. So 12 does not equal 0. The book did a little bit different, but we can do it either way. Here, yeah, the 12 does not equal 0. So there is no solution because inconsistent equation. B, 3x minus 4 equals 2x minus 1. So let us try this one. Okay, distribute. We get 3x minus 12 equals 2x minus 2. So let's move this to that side by subtracting 2x. Let's move that to that side by adding 12. So that gives us 3x minus 2 equals negative 2 plus 12. Sorry, that's 2x, so that tells us x equals negative 2 plus 12, which is 10. Therefore, we have an answer. If I were to plug this back into the original equation, it would work out. And so that tells us that it is consistent, has solution. Try this on guided practice 1, 2, and 3. Then we can justify. infinitely many solutions. So we've seen the ones here, like where there's one solution. We've seen those. We can solve them. We've seen the ones with no solutions. They're inconsistent. Inconsistent equation. So let's see if there's an infinite number of solutions. Okay? Consider the equation 3x plus 5 equals x plus 2x plus 5. If you try to solve it, we'll see what happens. So, let's combine like terms. First on this side, so those together become 3x plus 5. Over here we have 3x plus 5. Now if we subtract 3x from both sides, that gives us 5 equals 5. Okay, 5 equals 5. It is an identity. So when you have something that's an identity, it's true, it's consistent, but it doesn't tell you what x equals. So that means that there are an infinite number of solutions. Example 5. A. Tell whether each equation is an identity. Justify your answers. So it's identity, infinite number of solutions. Let's try it. 7x minus 10 equals 3x minus 2 plus 4x minus 1. Okay, first let's distribute. And so we have 7x minus 10 equals 3x minus 12 plus 4x minus 4. Let's redistribute. 7x. Well, let's reorganize. 3x plus 4x minus 12 minus 4. Now we can combine like terms. 7x minus 16. Now let's subtract 7x from both sides. I think I did something wrong. What did I do wrong? That's what I did wrong. 3 times 2 is not 12. It is 6. It makes a lot more sense. So then here we get negative 10. All right. Being careful about your problems. So we subtract both of those and we get negative 10 equals negative 10. Is that true? Yes. Is it an identity? Yes. So we have an infinite number of solutions. B. X over 3 plus 2x plus 1, 5 equals 1/3. Okay, let's try to figure out the solution. So first we will write them all having the same we'll write these two as having the same least common denominator. So we have to multiply those both times 5x over 15, plus multiply both those times 5 times 2 times 2x plus 1 over 15 equals 1/3. Now we can simplify that and simplify that. So that becomes 1 because it's divided by 5. That becomes 3. So we get x over 3 plus, we multiplied those together, 10 2x plus 1 over 15 equals 1/3. Oh, sorry. The whole reason we did that was okay. Writing this back again. We did that for a purpose. 15. And then this one we had to multiply times 3. Because we multiply both those times 3, we multiply both those times 5. So this is still 5x. That is still 15. This would become 3 times 2, which is 6, over 15. Good, so now we can add them. So it's 5x plus 6, 2x plus 1 over 15 equals 1/3. Awesome. Now let's distribute. 5x plus 12x plus 6 over 15 equals 1/3. And let's combine these like terms. It's 17x plus 6 over 15 equals 1/3. Now let's multiply times 15 and multiply times 15. We get 17x plus 6 equals 15 over 3. And let's subtract 6. Subtract 6. That gives us 17x equals 15/3, which we know is 5 minus 6. 17x equals -1. Divide both sides by 17. That gives us x equals -1 over 17, and that is our answer. So here, it's not an identity, it's a consistent equation. Consistent. Therefore, we have one solution. Try that. Guided practice 4 and 5.